For today's warm-up, I'd like you to take a look at this histogram. It shows the distribution of the lengths of words used in Shakespeare's plays, and I'd like you to find the median, the shape of this distribution, and the range of this distribution. So please pause the video for 5 minutes to calculate each of those three. Okay, for the median, I actually think that's the hardest question of the three. I need to find the value which has half of the observations on the left and half of the observations on the right. Now that is not just going to be the middle of 1 and 12 because these observations over here have a much higher frequency than these observations over here, so they're going to be weighted more. What I would do is find the height of each of these bars, find the number of observations in each. So I'm going to call this about 5. I'm going to call this a height of about, 17, maybe 22, 24. This is all approximate. Regardless, we should probably land on the same answer. I'm going to call this 12, 7. I'll probably call this 5, 4, 3, 2, and then I'll call this 1 and 1. And so then the next thing I'm going to do is find what all of these add up to. And I believe they add up to 103. Okay? And so if you remember the trick I showed you, take the number of observations plus 1 and divide it by 2. And I get 52. So the median is the 52nd observation. So if this contains 5, this contains 17, that means that contains up to observation number 22. I'm just adding them together. And then if I add on the next one, add on 22 more, then what that means is by the time I'm done with this bar right here, I'm on observation number 44. Which means that if I add on the 24, that puts me at, 68? This is the bar that contains the middle observation. This is the bar that contains the 52nd observation. In other words, one of these 4s, the answer is 4 letters, one of the values that fell in this observation had 52 observations below it and 52 above it. Okay? Another thing you could have realized is that on the y-axis wasn't actually the frequency, but it was the percent. So really, in eyeballing these numbers, I overshot a little bit. They should have added up to 100 because the total should be 100%. So I'm really looking for the bar that contains the 50th observation, which still would land me in this 4 letters per word bar. The shape of this distribution, hopefully you identified as skewed, which one? Right? It's the direction of the tail. So since the tail is on the left-hand side, on the right-hand side, the shape is skewed right. And then the range, if you recall from your summer assignment, is the maximum minus the minimum. So the maximum is 12, the minimum is 1, so this is a range of 11 letters. Please, please, please do not say that the range is from 1 to 12. That is so wrong. The range is a single value, 11 letters. So this distribution has a median of 4 letters per word, is skewed right, and has a range of 11 letters. All right, so I keep using this word distribution, and what that means is the set of all values that the variable takes on, along with how frequently each value occurs. Basically, it's a list of all the numbers that happen. Okay, so we're taking into account repeats, we're taking into account all values that actually occur. In order to summarize a distribution, this is your first really big AP statistics skill, summarizing a distribution. We need to give the center, the shape, and the spread, and we need to give those in context. Context is key. So what I mean by that is if the problem is about bunny rabbits, I need to know from your summary that it's about bunny rabbits. Okay? I'm going to talk about what these 3 things mean and the ways that you can address them. They're not terribly difficult. You just did it in the warm-up. But on the AP exam, there absolutely will be a free response question that asks you to summarize a distribution. And in order for you to do that, you need to address center, shape, and spread. The question will not mention center, shape, and spread. It'll just say to summarize, you need to know that that means center, shape, and spread. Oh, look how important it is. Center is the middle. We can give mean, we can give median. I crossed out mode because it's kind of babyish. Really, we're going to use mean or median. You pick. If it's easier for you to find the mean, find the mean. If it's easier for you to find the median, find the median. In the warm-up, we chose to find the median. For shape, please refer back to summer video 1. Okay, remember, actually I'm going to go through our choices as a quick review, but really you learned about that in your summer assignment. For spread, that tells me how much variability the data has. Okay, and I'll address that one more later. So of our 3 big characteristics, center, shape, and spread, I'm going to start by reminding you of the different shapes that can be presented in a graphical display, such as a histogram. So the first one that I'd like to emphasize is the uniform distribution. In a uniform distribution, all values occur roughly equally. So the heights of the bars, we're looking at the y values, the heights of the bars are all roughly equal. In a distribution such as this one, we would call this approximately normal. It's a bell curve. The middle values occur with the highest frequency, and then the more extreme values, both above and below, decrease in frequency in a symmetric way. So this is symmetric, single peak, a bell curve. It's really, really, really important if you are describing a distribution that you use the word approximately. If you're describing a shape as normal, you don't get to say normal, you say approximately normal. We'll talk about the reasons for this more in chapter 2, but the word normal has a really, really specific mathematical meaning that you can't just tell from looking at it. So we need to say approximately normal. Sometimes we have something that's sort of like a bell curve but has a longer tail on one side than the other. So this one we would call skewed right with the tail on the right. And then this one we would call skewed left with the tail on the left. So wherever the longer tail is, that's the direction of the skewness. Skewed right and skewed left. And then finally, so real quick, go ahead and shout out, is this skewed right or is this skewed left? Hopefully you said skewed left because the tail that I see is on the left. Finally, bimodal. In a bimodal distribution, I have 2 peaks. Now this is kind of weird. If I were looking at this first, I might have a hard time deciding the shape of this dot plot. However, if I try and smooth over it, I see that I kind of have 1 peak and then 2 peaks. Those peaks don't have to be equal height. We just need to see a clear definition of 2 peaks. Other features we should mention, gaps, outliers, and clusters. A gap is basically a space between groups of data points. So I might note that there's a gap between here and here in this histogram, in this dot plot. An outlier for now is just an unusual value, a value that kind of stands alone. It's going to be an extreme, so either an extreme low or an extreme high. If there were, for some reason, a dot here in the middle, okay, I wouldn't call that an outlier because it's really in the middle. An outlier is going to be a low or a high, okay? We'll talk more later about how to define those a little bit more mathematically. And then a cluster is a grouping of points that are close together but far from the rest of the data. In fact, I think I would describe this dot plot as 2 separate clusters of points, having this lower cluster and then this upper cluster with a gap in the middle. So that's all I have to say about shape. You're responsible for 5 shapes: approximately normal, skewed right, skewed left, uniform, and bimodal. Next, I want to move into measures of center. Hopefully this is also review. The primary measures of center that you'd be expected to be able to pull off of a set of data or a graphical display are the mean and the median. As I mentioned yesterday, mean is usually abbreviated with an X bar. That's an X with a bar over the top of it. And we find the mean by adding the individual values and dividing by the number of observations. It should be noted that the mean is sensitive to the influence of extreme observations. In other words, if I have some skewness or I have an outlier, the direction of that skewness or that outlier is going to tend to pull the mean towards it. You're going to see this more in a lab that we are going to begin tomorrow, actually. And we're going to talk about this more after you do that lab. The median is the other preferable measure of center. We abbreviate that with a capital M. And the median is the midpoint of a distribution, okay? It's in the middle. Remember yesterday we said it's observation number n plus 1 over 2. So if there are, let's say, 11 observations, then the middle one, counting from either end, is going to be the one in the 6th place. So it's not 6, it's the 6th number counting from either direction. If I have an even number of observations, okay, if this comes out to a decimal exactly, then you're going to average together the middle two. Okay, so you're going to find the middle two observations and add them up and divide by 2. The next thing I want to mention are percentiles. We'll talk about these more when we get to chapter 2. And I hinted at this yesterday, but percentile gives me what percent of values are at or below a certain value. Percentiles come up big when you have a baby at home, because when you take the baby into the pediatrician and they get weighed and measured and things like that, they give you percentiles. So when my daughter was born and we took her into her doctor's appointment and she measured her and things like that, it came out that her height, let's say, was at the 95th percentile. Okay, that meant that she is taller than or the same as 95% of babies her age. Okay, so to calculate percentiles, we just calculate what percent of values are at or below a certain value. Let's say you score an 87 on your first test, and let's say that 15 of your 25 classmates, including you, got that score or lower. So to calculate your percentile, this 87 doesn't matter. What matters is that 15 people got that score or lower, and that there are 25 people total. So 15 out of 25, I believe that's 60%. So you're at the 60th percentile. You scored the same or higher than 60% of your peers. The quartiles are specific percentiles. So the first quartile is, listen to this, the median of everything below the median. Okay, so let's say I have a set of data, and let's see, I have 1, 2, 3, 4, 5, 6, 7 numbers. Okay, so this middle number, the 4th number, is going to be the median. The first quartile, which is sometimes abbreviated as Q1, is the median of everything below the median. So it would be this guy, okay, assuming these numbers are written in order. That's going to be the 25th percentile, okay? 25% of observations are there or lower, approximately. The third quartile, which is abbreviated Q3, is then the median of everything above the median. So that's going to be the median of the 3 observations above the median, which is going to be this guy. That one, what do you think? It is the 75th percentile. So this brings us to something called the 5-number summary. The 5-number summary is a numerical description of a set of data. It can take a very large set of data and summarize it in a pretty succinct way. And in order, it consists of the minimum, the first quartile, the median, the third quartile, and the maximum. A box plot, which when you were in, I don't know, Algebra 1 or something like that, you learned of it as a box and whisker plot. They look something like this. Okay, it is a graphical display of the 5-number summary. So let me draw a bigger version of it down here. The box in the middle spans the two quartiles. And so the box begins at quartile 1 and ends at quartile 3. The line is the median, and then the whiskers span out to the minimum and the maximum. I want to show you just how to calculate the 5-number summary by hand real quick. All right, so let's say I have a set of numbers 1, 2, 2, 5, 7, 9, 12, 1, 2, 3, 4, 5, 6, 7. Another 12, and then a 20. Okay, so right now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 observations. So the middle one is going to be, let's see, 9 plus 1 is 10. 10 divided by 2 is 5. The 5th observation, 1, 2, 3, 4, 5. 7 is the median. Okay. Calculating quartile 1 means calculating the median of everything that's less than the median. So the median of these 4 numbers, well, with an even number of observations, Q1 isn't going to be an actual observation. It's going to be in between 2. So the middle 2 over here are the 2 and the 2. And so Q1 is equal to 2. The minimum is obviously 1. Similarly over here, Q3 is going to be the average of these two. I didn't mean for it to come out this way. Q3 is 12, and then 20 is the max. So the 5-number summary is going to be 1, 2, 7, 12, 20. If I had an even number of observations, so let's kind of use roughly the same data set, but I'm going to add one more. Okay. Now I have 10 observations, which means that the median is going to be between observation 5 and observation 6. So 1, 2, 3, 4, 5, 6. The median is going to be right between these two. So I have 7 and I have 9. If I average those together, I get 8. The median is actually equal to 8. Then I look at everything to the left of the median. So 7, 5, 2, 2, 1. The median of those is 2, so that's Q1. And again, the minimum is 1. And then for Q3, I look to the median of everything to the right, which would be this 12. And then with 40 as the max. So now my 5-number summary is 1, 2, 8, 12, 40. A quick note about making box plots by hand. Please, 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 when you make a box plot, I do not, this is a non-example, I do not want you to first draw the box plot like this and then label your x-axis. I need you to realize how ridiculous this is. This is implying that you think the distance between 12 and 40 is the same as the distance between 1 and 2. And I hope that we understand that that's not the case. The whole point of a box plot is to indicate roughly the shape of my distribution. So what I want to see is an axis that is scaled first. So let's say we want to go up by, I don't know, tens. 10, 20, 30, 40. My minimum is 1, so that's going to go about here. My Q1 is 2, so that's going to be really close to it. My median is 8, that's going to fall right about here. My Q3 is 12, so that's going to fall about here. And then my maximum is 40. This gives me a very different shape than the first one does. If you did what we did up here, then you would always talk about box plots being symmetric because you always draw them that way. This shows me I have this really long tail on the right. This is probably a skewed right distribution. Okay, so that's really, really important. Okay, the next thing I'd like to do with you is have you get out your graphing calculator, and I'm going to show you how to calculate the 5-number summary and make a box plot using your graphing calculators and the data that I gave you yesterday on students' ages. So please get your graphing calculator out. And I'll bring up that age data as well. I'm not sure if you kept this data in your calculator or not, so I'm going to go ahead and remind you how to re-enter it. Remember, after you turn your calculator on, you hit Stat and Enter. And then in List 1, go ahead and enter these numbers. Please pause the video here and just let students enter those numbers into their calculator. Okay, so now that you have that data back in your calculator, I'm going to first show you how to calculate a 5-number summary. So I want you to get scared and quit. And I want you, actually we need to set up something just for the first time we do this. I need everybody to hit the mode button. And when you get to the very bottom of this mode screen, some of you with a newer model will have it ask about stat diagnostics. I need you to put your stat diagnostics so that it's on. And then some of you with an even newer model probably have something that says stat wizards. That sounds like a good thing. It's not. So if you have stat wizards here, I don't. This is an older version. But if you have stat wizards, I need you to turn that off. So stat diagnostics on, stat wizards off. Okay, so go ahead and quit. You only need to do that once, and then if for some reason you reset your calculator or something like that, you may have to do it again. Now to calculate the 5-number summary, I need you to hit the Stat button again, and I need you to hit the right arrow over and go to the Calc menu. Your first option is 1 var stats, in other words, 1 variable statistics. Hit Enter. And then hit Enter again, and it's going to give you a whole bunch of stuff. Some of it's important to us right now, some of it's not. The first thing I see is X bar. Can you remember what that is? X bar is the mean. So the mean age of this group was 206.1 months. Okay. The next few are numbers that we're not going to concern ourselves with now. N equals 19 tells me that there were 19 observations. I need you to hit the down arrow. It has more to tell us. Oh, hello, here's the 5-number summary. The minimum is 180. The first quartile, or Q1, is 204. The median is 208. The third quartile is 212. And the maximum is 217. By the way, Q1 and Q3 are sometimes also called the lower quartile and the upper quartile. So if you ever see that terminology, that's what that means. Okay, let's also make a box plot. This is pretty easy to do since you already know how to make a histogram. So I want you to go back to the same place where you made a histogram. That was second, y equals. Probably your other plots are still off and plot 1 is on. That's exactly what we want, so that's fine. Hit Enter to enter plot 1. Make sure it is still turned on. And for type, I want you to select the one that looks like a box plot. Now, there are 2 that look like box plots. I have this one and this one. I want you to always, always, always select the first one. I'll tell you why in a second, but for right now, let's do that. You have to hit the right arrow. If yours is split in the screen like this, hit the right arrow to go from the histogram to the box plot. Okay. XList is still list 1. That's the list that I'm making my box plot off of. The frequencies are still 1 for reasons that we talked about yesterday. And then you can choose what type of, I guess, dot that it uses to mark your min, Q1, median, Q3 max. I just like to use the bigger one because it's easier on my eyes. So yours should look exactly like this. I get scared, so I quit. And then to make a graphical display show up, again, remember we hit zoom and then we go to option 9. And there is my box plot. Now, this is a really nice example because of this right here, okay? The reason we chose the first box plot as opposed to the second is because the first box plot is something called a modified box plot. In this class, we always want to make a modified box plot. So if you're asked to make a box plot, assume that they mean modified. What I mean by modified is that it pulls out the outliers. And it identifies them with, in this case, a little pixel guy, or sometimes if we draw them by hand, we might mark them as like an asterisk or something like that. So what that tells me is that my minimum, my 180, is in fact an outlier, okay? I'm going to hit trace, and if I hit the left arrow, it's going to start me over here on the far left. The minimum is 180. The whisker then starts at the next highest non-outlier. So 194 is not my minimum, 180 is my minimum, but 194 is the lowest number that is not an outlier. Quartile 1 is 204, the median is 208, quartile 3 is 212, and the maximum is 217. So again, this is a modified box plot. It calculates outliers according to a rule that I'm going to teach you next week. And then it marks them with like a little box or an asterisk or something like that. I can have multiple outliers. I could have a box plot that looks like outlier, outlier, here we go, and then maybe there's another outlier over here. Still, the minimum is this one. This is nothing. This is nothing. This is Q1, median, Q3. This is not the max. This is the max. Okay? This is just another outlier. This is the smallest number that's not an outlier. But if we were giving the 5-number summary, that would be these 5 values. Okay? Just to make that perfectly clear. That is the end of this lesson. So here is homework assignment number 3. Please stay on top of these guys. They are going to pile up really quickly. And if you leave all of this to, right before the day of the test, it's not going to end well for you. The other quick reminder that I want to give you is that your summer assignment is due tomorrow. So your summer assignment must be turned in tomorrow. That's it for today's lesson. Tomorrow you are going to engage in a lab that's going to put some of these ideas in sort of a hands-on manner. And then next week we're going to have a video on Monday. Tuesday we'll review a bit, and then your quiz on everything we'll have covered through Monday is going to be next Wednesday. So Wednesday, September 2nd, you're going to have your first quiz.